Well, now let's take a look together at example number 3. Let's suppose that f of x is a function that has this derivative here. So notice I'm not going to need to calculate a derivative for this question. I'm already given it. Can I find the intervals on which this function is increasing and decreasing? And can I find the x values where all local extrema, that is, local mins and local maxes, can I figure out where those occur? Not what they are, but when they happen. Okay, well, this should be pretty easy because, again, I already have my derivative. So all I would need to do is to start by testing when is f prime of x going to be equal to 0 and when is it undefined. So I can see here that f prime of x is going to be equal to 0, of course, whenever e to the x is equal to 0, or x plus 5 quantity squared is equal to 0, or x squared minus 4 is equal to 0, right? I mean, I could see each of these. Whenever this actually happens, if any one of these pieces of the product is 0, the whole thing is 0. Now, we've seen before that the value of e to the x, remember, can never equal 0. I just have to think about the graph of it. Over here, I can see that this middle piece could be equal to 0 if x was the value of negative 5. And over here, if I added 4 to the other side and then square rooted, I would see that I could have x being equal to plus or minus the value of 2. So I have some critical points right now. I now still have to check when is my derivative undefined. Well, it's never undefined because e to the x always spits out values, and the rest of this is just a polynomial. So this is a polynomial multiplied to an exponential, and I'm never going to have that be undefined. So this here is never undefined. So I'm going to take my values and I'm going to put them here on a little number line. Again, my values of x and f prime of x. So I put these in order. I have negative 2. I guess I should put negative 5 down first. That would be the smallest. So negative 5, negative 2, and 2. And I don't really need to worry too much here about spacing because this is just a rough picture. Well, now I can start doing some test values. So let's go ahead and think about what we're going to get up here. Now, I should probably note right away that no matter what happens, e to the x is always going to spit out a positive number. Same thing with x plus 5 all squared. That's always going to be positive. So the only thing that could possibly affect the sign of the results that I'm going to get is this last piece. If this last piece is negative, the whole product is negative. And if this last piece comes out positive, the whole product is positive. So let's start by plugging in a value like negative 6. Notice if I plug in negative 6, negative 6 squared minus 4, that's definitely going to be a positive value, and so I get a whole positive product. If I plug in a value like negative 3, now notice that would get me like 9 minus 4, that's still going to be positive over there. If I plug in a value in between negative 2 and 2, maybe like a 0, notice that this piece would be negative, and so I'm going to end up here with a negative result on this interval. But if I plug in a value like a 3 or a 4 over here, this final piece is back to positive, and so I'm going to end up with this piece being positive as well. Okay, so I can immediately start to see a couple different things. First off, f of x is increasing on the intervals from negative, I should start negative infinity to negative 5, right? That's this first interval. Then also from negative 5 to negative 2, that's my next interval. And then also my last interval of 2 to infinity. Those are all the spots where my derivative is positive, so I have tangent lines sloping up, and so my graph is going up. I can then also see there's only one interval here where my function is going to be decreasing, and that's from negative 2 to 2. Well, now I can start to think about local mins and maxes. Local min and local max. Let's think about where these happen. Notice here that what's happening on my picture is that my graph is going up, I get a slope 0, and then my graph goes back up. So over here at negative 5, I don't really get a min or a max because I didn't change from positive to negative or negative to positive. I went up, leveled out, and then went up again. But now I'm going to see that my graph is going to go down, and then I'm going to level out, and then my graph is going back up. So I'm going to get a picture something roughly kind of like this. So this is going to tell me that I have a local max when x is negative 2 and a local min when x is positive 2. So my local min occurs at x equals the value of 2, and my local max occurs at x equals negative 2. And nothing important happens over at the value of negative 5. Notice it's again impossible right now for me to actually find where the actual maximum and minimum values are, like what are the y values that go at these x's, because I wasn't given an original function. And that's totally okay. There's nothing wrong with that. Sometimes I'm just not given something, not given a function f to actually work with.